Okay, so like I mentioned, we have already inadvertently run through some of what we're supposed to be covering in this lesson in these troubleshooting sessions. So I think that's great because you get to see it live, right? As opposed to just seeing in a slide like some abstract notation. You get to see these things in context. But before we jump into that, let's go back a little further and talk about Unix from a broader, bigger picture perspective. Um, it's essentially an operating system, and there are variations of it that you are working with. So a lot of us are working with Mac OS. We see for Unix-like systems, which are essentially different flavors of Unix. You have things like the Chrome OS, the Android operating system. Linux itself is a variant of Unix. And then Unix-based machines like the Mac OS are, I'm going to cheat and look 'cause I don't remember. So they're not necessarily derived from the original Unix system, but they mimic its behavior. That's the Unix-like systems. Okay, so I got that mixed up. The Unix-based systems are the ones that are like different flavors. They're derived. And then you can think about Unix-like systems being an extra layer removed from that because they more so mimic the behavior rather than um, are based off of it. And so that means there's a lot more freedom, right? A lot more freedom for developers to create variations. That's why you have so many Linux distributions, whereas with Mac, you are essentially tied to their one version of the OS and it just updates every year or whatever. In a nutshell, this is your Unix architecture. You have your hardware, so like your motherboard, CPU, et cetera, et cetera. And when your computer starts up, the kernel is the very first thing that loads, kind of like a kernel of popcorn. It's going to turn into something else. I don't know. I think that's a story of the origins of that name. And this essentially is the control point for all of the hardware. So everything physical is going to be going through this kernel in order to interact with the actual shell or operating system or program applications. If you've done any like hacking or modifications of things like a PlayStation Portable, you've you're probably familiar with a kernel and having to like go into boot mode to change that sort of stuff. So that's what it is. Also, same thing with Windows, for example, right? When you start up a Windows machine, you're going through, do they still call it DOS, DOS? You're going through essentially a, a system specific to the kernel. It's like the interface for configuring and interacting with the kernel directly. And then it loads up your operating system, and that's what's going to have your shell that you're engaging with right now. So that's Unix architecture in a nutshell. Directory structure. We talked about the tilde symbol, which takes you to your home directory. The other, that's a really strange looking slash. The other symbol that you're going to want to remember, it should be a forward slash, but that's going to point to your root directory. And from there, you're going to have like your configuration folders and whatnot. So let's see if I also increase my size. Yeah, if I do CD to I'm already in there, but that's my home directory. It's where like all my user stuff is configured. But if I go to my root directory, this is the root of your system. You cannot go up any further. It's just not possible. So I don't know if this is a good time to talk about absolute versus relative paths. I'm going to say it. I kind of believe in having repetition of topics, right? Even if we're going to cover this like 2 or 3 or 4 more times, it's good to hear it repeatedly just to drill it in. But when we're talking about absolute versus relative paths, does anybody want to shout out and say what it is?
I can go.
Sure.
So absolute path, I mean, probably won't use the best words here, but absolute path starts at your home directory and goes down the file tree to whatever the file is going to go.
Mhm.
Whereas the relative path, the way I think about it is the home directory or some kind of mother directory that only lives on your computer doesn't exist there. And it's relative to all of the folders that are in the same package or in the same world as the same file. It's easier when you have a picture, so much easier when you have a picture. So
Yeah.
um, if you have a web page and the web page has 3 pieces that you're going to display on their 3 pages, then those are all relative to the web page's domain or the area that the web page is contained in, right? And it
Mhm.
might be in different files. If HTML file might be in the HTML folder, and the CSS will be in the CSS, and the JavaScript in the JavaScript, and they could be relative to each other in there. But when you tie it to the home directory, which is like lens directory, no computer has lens directory but lens computer. So that therefore, you mean my knowledge is you don't want to do the absolute path. You want to stay in the relative path for the most part. Spoiler alert, because that way it works on everyone's computer when you download the system, not just your computer and your home directory. I hope I said that all right. A picture would have been better.
Yeah, definitely a lot of valid points in there. A lot of good examples too about relativity in different contexts. Julio, I think I saw your hand. Did you want to take a stab at this too?
Yeah, it's just very simple. The way it was explained to me is the absolute path is like the full address, or let's say, I'll give a quick example. If you're given directions, you start from the very beginning, you're going to make a left, make a right, you give the full path itself.
Hmm.
Absolute is, or relative is like currently where you're at. So if you do CD and then period, period, you're just going to go one directory before. So it's relative to where you're currently at. So again, it's very simplistic, but that's the way it was explained to me.
Simplistic isn't necessarily a bad thing, especially when we're at the start of the curriculum. That's easy to digest. It's easy to remember. And like Len was hinting at, when we get to a point where you're importing modules and whatnot into your environment or a file, you'll have the choice of either specifying the absolute path, which is going to start at a symbol, basically, at either your home or your root directory, or your relative path. And this is just a very key thing to know because you're going to be passing paths in a lot, maybe a lot more than a standard developer, because we're working in DevOps, we're working with systems so much more. We're working inside so many different environments. You're working in a machine, your local machine, in which you could create virtual environments. You could create Docker containers. You could spin up Kubernetes and create pods. You could hop into a pSQL terminal, a Python terminal. These are all different environments that are partitioned in a sense. And so you, as a DevOps engineer, need to become comfortable with recognizing where you're in and how to move around. So relativity is essentially a key part of that, a foundational part of that. Um, if you're trying to find a file, it's not in the current directory, it's one directory above, you could start with the dot dot symbol and then type the rest of the path. So this is telling me what's above myself. All right, thanks, Phil. See you later. And well, kind of lost my train of thought. Yeah, I mean,
Relative, start with dot dot, one up.
well, I wouldn't even say that because what the dot dot symbol is the symbol that represents the parent directory of the directory you're currently in. Use cases for the period symbol. When you're, let's say, trying to access a folder, for the most part, you could type the name of a folder inside of your current directory. It's the same thing as doing dot / and that directory name. Because if you were to start off with just the / alone, that's the symbol for the root directory of the machine, and it's going to throw an error because that doesn't actually exist in my root directory. Does all of that make sense? Nothing too confusing about that? Cool. So that is essentially the directory structure. You have folders within folders within folders. It's nesting, and you navigate using these symbols. Right. Here's another visualization of that. You have a folder that could either contain another folder or a file. And if it's a folder, it can contain more either folders or files. Unix only recognizes these two types of things. Is it a folder? Is it a file? Ooh, top 50 commands you must know. Yes, PWD is one of my favorite commands. When you're trying to get a lay of the land and navigate your machine, your environment, because that's a key part of being an engineer, PWD could be super helpful. It will print out the present working directory or print the working directory that you're in, however you want to think about it, whatever helps you remember it. And this will just come in very handy when you're troubleshooting, when you're trying to like navigate and find where a folder or a file is. It's just super handy to use. CD, we already know this one. It's for changing directory. Make mkdir. I think we asked somebody to do that earlier, either Flo or Haisa. We asked one of you two to make a folder, I think. MV is move. And so, like its name implies, it will move a file. So let's actually just make some kind of scratch directory. And let's go in here. Let's code a few files. I'm going to use touch instead. File1.txt, file2.txt. A lot of times when you're using commands, you don't have to do it one by one. So commands, for the most part, they'll all behave however they were programmed. And a lot of times you'll be able to pass in multiple arguments. These are arguments, parameters, that's kind of used interchangeably. I'm letting it know that I want to run touch on both of these values. And now if I do an ls, it's going to show that those files exist. Now move can move these files like its name suggests. Where is this going to move to? Somebody tell me.
The main directory?
The main directory?
Or is it one above? I forget.
Yes, the one above, the parent directory. So now if I do that, if I go up one directory and run another ls for list, I see that the file has been moved. And now I can move it back. File1.txt. Though the syntax for this, because different commands will have different syntax, is the first argument is the file I want to move, and the second argument is the location of where I want to move it into. So I just said with the previous example that oftentimes you could pass in multiple arguments, but of course that's not going to be the case with every command. Every command is programmed differently. In this case, move expects 2 arguments. So I'm going to go ahead and toss it back into whatever folder I want to exist in and go back in there. And we see that it's been moved back. Now, I've pointed out twice how move does what it says it does. It moves a file. And this is because I want to also point out that it's capable of doing something else that might not seem intuitive. Move is also used to rename files. So if I want to rename file 1 to file 3, I can move it from file 1 to file 3. Whoops. We don't want that MV in there. And now if I do an ls, file 1 has been converted to file 3. So that's something to remember about move. If you need to rename something, you pass in the previous name for the first argument for move, and then the new name, as well as a new path if you want to move it while renaming it as a second argument. All right, CP is copy. Similar to move, you pass in two arguments, file2.txt, and then the destination. In this case, I'm going to have it in the same directory, and I'm going to call it file2b.txt. Now I do an ls, and we see that it's been copied. Okay, RM is for, somebody tell me.
Remove.
Yes, it is for removing. So let's go ahead and we can remove these files. Tab to autocomplete, ls, we see that there's only 2 files left. We could also run it on directories, but we will initially get this complaint. So this is again where arguments come in really handy. So I can run an RM with RF on Scratch. And what this does is, does anybody know?
I know.
Is it a recursive
It's
force?
Yeah.
Yes, it is recursive force. Awesome. And that means it's going to go through every subdirectory in from scratch and onwards, and it's going to force a delete. With force, I can get it to delete something that it was initially complaining about. So that's the RF arguments for RM, and they're separate arguments, right? But we just combine them into one. Let's see. We're not going to run through all of these. You've already seen touch. Cat is pretty cool. It's concatenate. It will essentially show the contents of a file. There are other ways to do that as well, and I know one of the lessons will go over all of those in more details. Let's go back to ls. I think you've seen me do LSA for showing everything, which includes hidden files. We could also attach things like L, which will, I forget what it stands for, but it's essentially like listing more of the files in here. And then H, can somebody tell me what H does? Let's see it in action.
Permissions?
Not permissions.
File size?
Sorry, what was that?
Is it file size? That's the only thing I see that really changed here.
Yeah, you're on the right path. It is essentially, in this case, it is. But what it stands for is human readable. And so maybe in a different folder, it might show us a different thing. But yes, it will slightly alter the results, what you see. And that's just another kind of argument that can be passed into commands, things that will change the appearance of other things. Let's see. Am I in a repository? I am not in a repository. Let's go to, let's go to our directory. And I'm going to go to class resources. Actually, that's not a Git repository. Let's go to this, because I do know this is a repository. I do a Git status. It's going to tell me, oh man, we got to cover Git as well. Yeah, it's going to tell me It's going to give me some information on Git. Just so I don't lose my train of thought, what I was going to do here is show this. This is an alias. It's git log all D is, I'm blanking on what D is. Forget what O is. G is graph. So that's why we're seeing this in like pretty colors. If I do a regular git log, that's what it tells me. It's not very pretty, right? So this is why certain arguments can help. They can help make things more digestible. So, oops. Did
Oh, I think it was Git that alias was all decorate one line and graph.
Julio put a little
yes.
cheat sheet in the thing there with A being all, D being decorate, O being online, G being graph.
Oh, you're great.
Yeah, what is a one line to
Yeah, yeah.
one line.
That's not me. Julio put it in the chat.
No, that's awesome. Cheat sheets are awesome. I love cheat sheets.
Yeah.
Actually, that's a point that I want to make. One of the things that will help you succeed as an engineer, especially in DevOps, is to take good notes, to write good documentation. Like that's going to be a big part of your job because it's community based. Let's back up and talk about DevOps overall, like DevOps versus software engineering. Software engineering, you're essentially concerned with your Jira tickets, your Agile tickets, creating functions and features. DevOps is a little more, it's more broad. It's essentially because DevOps isn't really a role. There are roles out there that are titled DevOps engineers and whatnot, but it's more of a philosophy, right? It's like a body of different like principles that pertain to both development and operations. And there are concepts like the DevOps lifecycle, which talks about best practices during development, during operation. Without these things, it's kind of like the Wild West out there. Different engineers, different people, different organizations will just do everything their own way, and it's kind of chaotic. And so DevOps was born out of this necessity to create some structure and foundation to systems engineering as our technology has continued to scale like in the past 2 decades. So as a DevOps engineer, culture is important, community is important, collaboration is important, because you are going to be in charge of things like the platform that software engineers are going to use if you're a platform engineer. If you're a site reliability engineer, you'll be in charge of reliability for all of the applications. And depending on where you work, that might look like either doing a job for them or teaching them how to do that job, like providing them the platform, but then having the expectation that they build out their necessary components as they need for their application, and that you are there as more of a guide, as a resource. So that's essentially DevOps in a nutshell. This goes all the way back to my point on cheat sheets. Yes, use cheat sheets. Yes, take very good notes, because otherwise you're turning this abstract knowledge into something that's shareable, and that's awesome. So yes, get in the habit of cheat sheets, of taking really good notes and sharing all of that as well. One of the expectations for this cohort is collaboration. I think this is more collaborative than the software engineering curriculum. Software engineering, you're essentially working in pairs, small groups from time to time, half the time alone on challenges and assignments, and then you don't group up until the end when you're working on your applications, right? That's not really going to be the case with DevOps. There's going to be less algorithmic challenges. There's going to be more learning learning, reading documentation, just constant learning and reading documentation, so that you will know how to configure different things, so that you can remember how to run various commands, so that you could troubleshoot. And troubleshooting is a very collaborative thing as well, right? So I'll leave it there. I'll get off my soapbox for now so we can continue with the lesson. Are there any questions on any of that? Cool. Okay, so yes, human readable is a -H, PWD lists your current path. This is there should be a link inside of the README to this, but it's a handy website. It's a resource among many that you could use to quickly reference something if you forget, and then you could add into your notes. Okay, so that is Linux in a nutshell. And now let's run through the Git CLI, which if you have your terminal up, which you should, who does not have the Git command line installed yet? You should be able to run things like Git status, Git log like I did earlier. Are we all there?
I actually ran into the same problem as earlier.
Oh, bummer. Okay. Okay. You still have GitHub accounts, so maybe work with, I don't know, just any random repository. But let's just run through like the exercise of grabbing a repo, cloning it down. I'm just going to make a junk folder here. And I'm going to grab any random repository. Maybe not so random. Actually, yeah, let's do that. I'm going to do one of the challenges. Oh, the syntax, the format for our curriculum, as you've already noticed, we have modules. Within every module are the weeks for that module and days. The one thing that's kind of different about evening and weekend classes compared to the immersive daytime classes is you'll have a different instructor on different days, because all of your instructors have full-time jobs, and we do this out of passion. So let's see. We were talking about cloning a repository. You have your lessons. Inside of your lessons, you'll have, sorry, I'm going to back up. Inside of your days, you'll have lessons, and sometimes there will be additional resources. Like in here, this is a repo that we're not going to walk through, but it's just another thing that you could look at that might help you create your own cheat sheet. This is a cheat sheet created by another instructor. If you like this format, use this format. That's the point of the page resources directory. And then the README is primarily what you're going to use to navigate around these things. It's going to give you a basic overview of what you'll be learning on that day, a link to all of the lessons, and the challenges. Challenges will exist on their own repositories. So you could click on a challenge and you can run through the whole Git flow from here, which means you can copy and clone this down. Now, this is kind of subjective, but what are best practices, right? Like, what are best practices for version control? Because that's essentially what GitHub is, right? It's version control. Different people are going to have different opinions. This is my personal preference. This is how I've done it since Platoon taught me. I like to fork everything. Maybe I'm a hoarder and I like to have a copy of everything in my own, I don't know, GitHub account. But the benefit of this is it's an additional layer of version control. And it also allows for some more cleanliness in how you're interacting with your different environments. And I'll show you that in a sec. So I'm going to make my fork. I'm then, instead of cloning down the original repository, I'm going to clone down my fork. And we do that with the exact same command, git clone. And now if I go into this directory, I forget what it's called already, Git Essentials, Git status to confirm that I'm inside a Git project. And if I do an ls-a, we could see that we have a .git and .gitignore files created. I think .git is actually a folder, but this is a fork. And if I were to type git remote --v for verbose, it's going to tell me what my origin is. I grabbed this clone on my local machine from this location. So now when I make changes, like let's just grab this README and make some change and go and insert because I'm in Vim, going to make this a little more enthusiastic and hit escape to exit out of that, write quit, bang to force it to do what I want it to do. And it has been updated. Now, if I do a git status, it's going to let me know that it's been updated. And this is where your Git, essentially, I like to think about it as a flow. This is where you'll run that. You have to run a Git Add, which will add it to kind of like this virtual staging. I don't know. I don't want to call it an environment, but it's like setting things aside, like you're packing up for a vacation or something, right? So if I add this, and I do another git status, it's going to tell me that these are the changes to be committed. So the reason that it's designed this way is so there's it's a step where you can check to see that the files you want to change are the files you want to change, the changes you want to change are the changes you want to change. And once you're happy with your changes, then you do a git commit. You're committing the changes that you have just staged. And commits will require a message. So -m for message. And let's say something like initial, or no. What did I do? I updated my README, right? I'm sorry if I'm throwing a lot at you, but this is a good opportunity to talk about version control as a practice. So there's major, minor, patch updates. And that's why you see a lot of times like a version will have like 3 different numbers. It's major, minor, and patch. What this means is if you're making a change and it's completely backwards compatible, that's a patch. It's probably a minor change. If you're making a slightly bigger change that may break like a function or two, that's a minor version change. But if you're making like a complete overhaul of your application such that users that try to run through their old setup in their application with your new version are going to run into issues, that's a major change. In this case, this is not major or minor, it's just a patch. So if you land at a company that is very particular about upholding certain practices, you'd probably do something like patch, maybe like your team name or something, whatever, and like the environment. Like that's going to depend on where you land. Let's say I landed a company that doesn't care, then I could just name it whatever I want. So junk change or something like that. But anyway, that's a commit. I've committed my change. It's got a message. And if I run another git status, I could see that everything is hunky-dory. It says that my branch is now ahead of origin main by 1 commit. And if we do a graph, which is super handy when troubleshooting commit issues, but it's kind of hard it's very abstract. You won't really know how handy it is until you go through commit issues and troubleshoot them yourselves. But this lets me know that where I am right now with my junk change message is 1 commit above the original commit, which is where I forked this from. Now I can go ahead and push my changes. Unless, was there anything else I wanted to go over here? I feel like I might be forgetting something. No, yeah. Let's just go ahead with the git push. Oh, yes, I remember now. I forked, right? So if I do a git remote dash dash v, we see that my origin repository is my fork. So yes, I wanna push my changes to my fork. So I'm gonna do a git push, and I'm gonna specify my branch, or sorry, my remote, and then the branch. If you only have one remote, you technically don't have to pass in your remote, but I say it's good practice. And then I could say, what's my branch? Ooh, I think I forgot to switch branches. We'll run through this again one more time without as much commentary, so y'all can get the hang of it. I did not switch branches. I'm still on main. Let's push on anyways. So push origin main. Now it's going to spit out this URL. And if I click on it, it's going to take me to my fork. And it's going to let me know, again, it's one commit ahead of the original repository. This is where you share this link with somebody on your team or a different team maybe, and then they could do a code review. So let's go to the original repository. Actually, no, sorry, I'm getting ahead of myself. Ooh, why didn't it make the... Okay, sometimes it might not create the pull request that you want. And so you could just do it through the UI if that happens, like that just happened right now. So I'm going to hit open pull request. And this is the link that you're going to share with another team member. So I'm going to create my pull request. Somebody in the team is going to see, yes, Julio?
Just had a quick question. So I've done some programs before, not too familiar with Git. I mean, I've used it for some projects here and there. But what's the difference between Git, push, pull, fetch? If you just go over that.
Yeah. So git push as an action is you're pushing your changes to the remote repository, right? Git fetch we'll talk about in just a sec because it makes more sense to think about git fetch alongside of git pull. So I push my changes to my fork. Now I'm another developer in the original repository, and I see that a pull request came up. So now I could review it. If I like it, I can add a code review. I could make comments and say, no, this is not acceptable. Or I could just go ahead and merge it. Are we working with a real repo here? Yeah, I'm not going to merge it. I'm going to deny it. Or let's leave it open, actually. So that's that. I'm going to grab the URL just as an example, the URL of this original repository. And I'm going to show you what I was starting to talk about earlier with remotes. So I forked this repository. Now I can have another remote set to this URL. I got to specify the name first. That's another argument. And I like to call this upstream. Now if I do my git remote dash, I think I could do one dash, right? Dash v, we see that I have two remote repositories. I don't know why it says both fetch and push. Like that's just, I don't know, like a really strange quirk to how this is designed because I don't know if there'll ever really be a difference. But usually there won't be. Like in this case, we see that both are going to the same remote URL. And the advantage of this is now I have two different repositories that I can interact with. So let's say I made my pull request, I push it to my fork, and somebody else on my team makes changes and they push it to their fork and it gets merged to the main branch. I could just go ahead and run a git fetch on my upstream. And there aren't really any changes. If there were, it would show them. And then I could do a git pull on my upstream as well. So this is pulling from git pull upstream main. You got to specify a branch in addition to the remote. And it's going to tell me that it's up to date. I wish we had a better example where it's not up to date, but this allows me to interact with two different repositories, or I should say copies of the repository simultaneously. I could push changes to the origin, which is my fork, and then I could pull changes from the source repository, which is now my upstream. These are arbitrary. You can name them whatever you want, but that's essentially one practice for Git that's adding an extra layer of security. The difference between fetch and pull. Git fetch is going to grab things like the commit history, the branches that have been created. It's not going to update the code at all. So this is, I like to run git fetch before git pull just as a good practice. Is it necessary? Not always. But again, like I said at the very start, one of the tricky things about Git is how there are so many different ways you can combine and mix and match these commands, right? I think it doesn't hurt to like run an extra command here and there, just as good practice. Because if I were to do a git pull without the git fetch, and let's say a teammate has, I don't know, pushed the change and it got merged to that source repository. And that's not a good example. Sorry. A better example is if I wanted to view a teammate's change, but not necessarily pull it down, I could do a git fetch. Because it grabs commit history and branches, I can then switch to their branch on my local machine without actually making any changes to my machine. I know this is a lot. This is why we're going to go over it again and again and again. So let's pause for a sec. Are there any questions?
No questions. I know this is quite a bit. I mean, I've worked on a few projects, and I get the whole Git init, Git add, commit. Um, I guess just going back to the example you provided. So I know we cloned the Charlie Platoon Git repository.
Mhm.
If we were to fork the clone that we created, um, is our clone considered the origin, or is the origin based off like what was originally posted by either you or whoever created that repository initially?
Yeah, great question. And this is partially what adds to the confusion are like naming conventions. Yes, the original repository is like the true origin. They also designed Git and the GitHub command line specifically to use origin as the default remote branch whenever you fork a repository down. So I think there is a Git command for changing the name of that remote. I've never used it. Yes. Git remote rename. If I wanted to, for clarity, I could have renamed my fork to fork. And then I could have named this origin, which does make more sense. Does that answer your question?
And yeah, I didn't know we could rename, so I'm glad you You brought that up.
Cool. This is super, super handy. If there's some functionality to a command that you think exists, but you really just don't remember, you could always hop into your browser and look it up, or you can just quickly type dash dash help. It will work with virtually any command if the command was designed well and the developer wrote good documentation. And this gives us a preview of like what kind of things can be done with this command. So we could see that in addition to renaming and removing and adding, we could even set like specific URLs or branches. Like this is probably why, by the way, that's probably why we see a difference in fetch and push, because you could set a direct URL or a branch for either of those use case. If you want to fetch from a specific branch, but push to another one, that's what these more nuanced commands are for. I've never used them. I've never had to. There's more than one way to do things and interact with these repositories in Git and GitHub. And you're free to practice your autonomy and just do this however you want. My opinion, and it is just an opinion, is that it does not hurt to run extra commands here and there, especially when you're learning. It might be confusing at first, but if you just learn it now, it'll be out of the way later, right? So that's Git in a nutshell. Let's see. I feel like I definitely didn't follow the curriculum like in a linear fashion. So let's double check where we're at and see if there's anything that I missed. Oh, and yeah, let's actually go back here. And let's run through this one more time, again, with less commentary, just so y'all could see. This is already up to date. Let's work with a new project. Let's pretend I'm working with like an entirely new project. I don't know. Let's see. Want to use any of those? Let's grab one of these. Yeah, let's grab this one. I'm going to grab this repository. I'm going to copy it to my clipboard. Or sorry, I'm going to fork it because I like to be extra careful. And now that I've forked it, I'm going to grab this link. I'm going to make a new project directory, not in the same directory that's already been established as a Git directory. And I'm going to clone that down. I'm going to cd into that directory. Tab, by the way, is super, super useful. But I said no commentary, so I'll return that later. I've gone into my new project that I've just cloned down. I like to get a lay of the land, so like by habit, I'll run ls in status, even though I kind of already know what's there. Then I clear my screen. I'm going to check out a new branch, and it's usually going to be named whatever I want to work on, right? So I don't know, change label. Like let's say I have a ticket where I have to change some label on a function. It just makes sense to name my branch that. And now I could also be sure to set my origin remote. So git remote add. I think this is where I specify the name that I want to name it. Yeah. I already have an origin, so I can't call it that. Upstream. And I'm going to grab the source repository. And again, these names are arbitrary, right? Like if you did it just flipped, if you clone down the origin repository, it's going to be named origin. And then you could add a remote to your fork. That works too. Because at the end of the day, what you're really doing is you're pointing to two different repos. And as long as you know which is which, you will be pulling and pushing to the right ones. So I'm adding this repository as my upstream. And we will get remote. -v for verbose. It will confirm that I've got to remote URL set now. And so I could interact with both. I could push changes to my fork, and I could pull changes from the upstream. Like, let's pretend that Chandra made some changes. I'm going to do a git fetch on the upstream. And I think I may have to specify what branch, because I'm going to separate branch now. I'm going to branch in my clone that doesn't exist in Chandra's upstream. So I'm going to specify that I want it from main, or he's got one of those old repos where it's named master. And I could then pull from that branch as well. And so now let's pretend there were changes. It's going to feed those changes into my local clone. And then I could go on my merry way working on my own actual changes. So let's just pretend that we're making a change to one of these. And status. Now that I'm ready to push, I'm going to do a git status to see what files have been changed, just to confirm that the changes I've made are actually changed, that they're recognized. And then I'm going to do a git add for the files that I want to add to my staging commit. And if I hit enter, I do another git status to confirm. It's telling me that these are the changes to be committed, as opposed to changes not staged for commit. It will always show the red and the green in separate text blocks, just for clarity. Now that they've been added, they are ready to be committed. So again, I'm going to commit. I'm going to pass in a message, change, and I'm going to hit enter. So now this change, it doesn't exist anywhere outside of my local machine yet. The commit is basically like a promise. I'm promising that these files will be changed. Now I have to deliver that promise. I have to push it to whatever repository I want to update. So I'm going to do another git status. It tells me that there's nothing to commit. The working tree is clean. That's just basically saying everything that's been changed has been committed. So now, I don't know how to describe working tree. Now the branch that you're on and everything that it's connected to is as it should be. So now I can push, and I'm going to push to my origin. I'm going to specify the branch because I'm on a different branch. Change label. And then it's going to spit out a URL for a pull request. And now I can add some notes. Yo, we made a change. And then we could create our pull request. And again, whoever is looking at the original repository, they can look at pull requests and see the changes that I've made. Any questions on this?
I have a question.
Sure.
You when you fork and then you clone, you say it's because you alluded to hoarding or copying too much, or why, what if you weren't do that, what's the normal, if someone wasn't quite the hoarder, what's your process? Because it's not what I'm used to doing.
Yeah, the fork is a step that honestly, even a lot of my teammates don't fork. And it also boils down to use case, right? If it's a bigger project, I'll be more inclined to do the fork because it's just an extra layer of version control to prevent changes that I don't want to make being made.
To your project or to someone else's project? Or either?
Somebody else's project.
Okay, so you're forking, so you have a connection to that project still, and then you're cloning it onto yours so that you can add the features or make the modification that you want. And then if it's like a big change, you're doing lots and lots of changes, you're going to push to your repository until it gets to the level that you're ready for. Okay, this is ready for to be possibly be merged into the actual project, and then you would push into the parent branch or the original branch for the pull request. Am I understanding that process?
Yeah, let's back up a bit. When you're pushing, you're going to be pushing to a repository,
Mm-hmm.
a branch on that repository, and you could push to either the origin or the fork. Let's
Right.
ignore the fork for a moment, okay?
Mm-hmm.
So let's say I'm working strictly with Chandra's repository, in which case I don't fork. I just copy this, I clone this locally.
This I'm tracking. I'm with you. I'm with you right now.
Cool, cool. So I do that, and then I work and I make my changes, and then I push.
Mm-hmm.
They are going to show up here as a pull request. That
Mm-hmm.
should still be available, but I'll also have the option of like committing my changes directly to this repo. Like, and if I do that, then I could potentially cause a production incident. What if I change something that was critical and then it caused the application to fail, right?
Mm-hmm.
Now, if I made that mistake on my fork, no harm, no foul. Yeah, so again, it's very subjective. It boils down to your level of comfort. How many extra steps do you want to take to just set up some extra precautions,
No,
right?
yeah, I'm with you. The thing is like if you fork, you push the fork. Can you get the pull request on the original thing via your fork?
Yeah, yeah. When you make a pull request, let's do another change just so let's see. Status, checkout, and branch. Let's see, less the I readme. Oh, it's lowercase. Okay. Change. Commit my change. And I do my push, let's say to my fork.
Mm-hmm.
I made a new branch, so I'm going to match that branch. It spits out this URL, right? And if we look at that URL, which is what's opening the pull request, this is where you could confirm where the changes are happening. I'm making my changes from my fork, so we
Mm-hmm.
have here over to the original Chandra's fork.
Okay. Okay. Yeah, I mean, I haven't done that. On our group project, I did a lot of pushing to the origin and the pulling, and then the whole time I was in X-ray, I made a folder called Code Platoon Work,
Mhm.
and I would clone into that CD into the file, delete the Git repository, and then just push my Code Platoon Work file as the whole. So I would just update that as the whole. I made my own repository that just had all the individual assignments kind of inside of it without. And then as I edited, I would just push it all up there. I don't know if I'm making sense, but
You said something about deleting.
the .git. So I made a file called Code Platoon Work
Mhm.
in X-ray, and it had my Git file or my Git file in there, my .git inside of there.
Okay.
And then I would go into the daily assignments and I would clone the assignment into that folder. But if you try and push that, it's going to say you have two repositories you're trying to push to, so don't do that.
Right.
So then I would CD into there and I would delete the .git file, and therefore it would disconnect it from the Code Platoon repository altogether. So there's no chance of me like dorking up the curriculum. And then when I was all done doing the assignment and having it, so I had my own copy of my work, I would push that repository. Does that make sense?
Making sense, but let's look at a few things that's happening here, right? When you're deleting files from the system, that's very different from when you're removing them in a Git environment because everything inside of Git gets tracked. So if you remove something, if you deleted something in a previous merge, that's going to show up in like the commit history, and always backtrack. Like let's say something got deleted in this version, right? I could just grab this hash and I could do like a git switch to that hash. Or let's see.
Oh yeah, I was deleting the history, the Git history.
Oh, yeah, I think he's deleting the Git history completely, not so you can't track it. You're creating a new Git in it.
Okay, yeah, but I guess the point that I'm trying to get at here is in like a work environment, in a team environment, there's also like accountability to be concerned about, right? So you want to kind of leave a trail of the changes that you're making, and
Yeah, no, I'm asking the question because I'm realizing I know why I did it for Platoon, and I still think that in that environment for learning, what I did was okay.
oh yeah,
And I'm understanding you're like by you explaining this, I'm fundamentally understanding what I was doing and how not good it was for a collaborative environment.
Mhm.
So I just wanted to I was asking for clarification. So yeah, no, I'm good now. Thank you.
Awesome. No, real good question though. Okay. I think that is the end of the things that we had to cover today.